In this video, you will learn about equations. So, question, what is an equation? Well, an equation is formed by placing an equal sign between either two numbers or variable expressions. So for example, let's say we had 12 minus 7 equaling 5. That would be an equation because you have an equal sign connecting two different statements. Now it doesn't have to be just numbers, it could also include variables. So for example, 4x minus 3 equals 9 is also an equation. Okay, there are two statements connected by an equal sign. And there could be variables on both sides of the equation. It could look like x plus 3 equals 3 plus x. All of these are equations because of the equal sign connecting the two statements. Now the two statements with variables has a special name given to it. That is called an open sentence. Okay, so an open sentence is a sentence or a statement that contains variables. Now with equations, we have what is called the domain of the equation. Domain is a set of numbers that a variable may represent. So for example, the domain of x in this example is 1, 2, and 3, meaning those are the possible values that x could be. And then the question asks, is the equation 4x minus 3 equals 9 true when x equals 1? And what about when x equals 2? And when x equals 3? So to answer the question, I can plug in those different values for x, the different domain values, and see which one would give me a true statement. So if we plug a 1 in for x, we would now have 4 times 1 minus 3 equals 9. Is that a true statement? Well, 4 times 1 is 4. 4 minus 3 is 1. 1 is not equal to 9, so that is a false statement. If we plug a 2 in for x, we now have 4 times 2 minus 3 equaling 9. 4 times 2 is 8, minus 3 is 5, which is not equal to 9. So that would be a false statement. Now what about when x equals 3? We can plug a 3 in for x. We have 4 times 3 minus 3 equals 9. 4 times 3 is 12. 12 minus 3 is 9. And so we have 9 equaling 9. That is a true statement. So my answer would be x equals 3. Okay, so if it makes a true statement, that means that is my solution, or one of my solutions. Now a few quick facts. 3 is called the solution. Okay, the answer is the solution. Another name for solution is also root. Alright, so solution and root are used interchangeably. We can also say that 3 satisfies the sentence. So satisfies is another way to describe what we are doing. Sometimes an equation could have multiple solutions or no solutions. If there are multiple solutions, I guess either way, if there's one or more, the set of all the solutions is called the solution set. So that's another term to know. When you find the solution set, when you find the answer, that is called solving the sentence or solving the equation. Once you find the answers, you can write the solution set with braces. So in this example, the solution set would be 3 because 3 is the solution. And notice the way we wrote our solution set. We wrote 3 inside of the braces. So here it says find the solution set of x plus 3 equals 3 plus x. Well, we can really plug anything in for x. If we plugged 1 in on both sides for x, we have 1 plus 3 equals 3 plus 1. Okay, that's a true statement. Plug a 2 in, we get 2 plus 3 equals 3 plus 2. Okay, that's true. Plug a 3 in. 3 plus 3 equals 3 plus 3. Yeah, that's true. We can plug anything in for x and make a true statement. So x can be anything. Therefore, the solution set can be any real number. So we would say the solution set is the set of all real numbers. And the symbol for real numbers we see here, it's a fancy R. And when you write it by hand, this is how I write it. I could write it maybe a little different. So I write an R like that, and then like that. So it's like a fancy R. All right. So if you were told to find the solution set of x plus 3 equals 3 plus x over a given domain, so over the domain of 0, 1, 2, and 3. Here we are limited because the only choices for x, the domain, is limited to 0, 1, 2, and 3. So I can only plug in those numbers. So therefore, my solution set would be simply 0, 1, 2, and 3. And once again, you could plug all those numbers in. So you plug a 0 in for x, you get 0 plus 3 equals 3 plus 0. That is a true statement. Plug a 1 in, we have 1 plus 3 equals 3 plus 1. That is true. Plug a 2 in, we have 2 plus 3 equals 3 plus 2. That is also true. Plug a 3 in, we have 3 plus 3 equals 3 plus 3, which is also true. So we could verify that indeed our answer would be 0, 1, 2, and 3. So a little side note, another way to show or to represent that the domain of x is 0, 1, 2, and 3 is we can say that x is an element of 0, 1, 2, and 3. So this fancy E is the notation for element. Okay, so we can say x is an element of 0, 1, 2, and 3. Or another way to state this is that x belongs to the set whose members are 0, 1, 2, and 3. So all that's saying is that x must belong to one of those numbers. X must equal one of those. All right, here's another example using that new notation. So here we are told to solve h times 3 minus h equals 2 if h is an element of 0, 1, 2, and 3, meaning h must equal either 0, 1, 2, or 3. So we plug in 0, 1, 2, and 3 in for x. And actually, that'd be in for h in this case. So plug a 0 in for h. I'll change that. Plug a 0 in. So now we have 0 times 3 minus 0 equals 2. Is that a true statement? Well, we would have 0 times, and then that is 3 in parentheses. So 0 times 3 would be 0, which is not equal to 2. So that is a false statement. Plug a 1 in. We now have 1 times 3 minus 1 equals 2. So in parentheses, we would have 2. So we have 1 times 2 equals 2. That is a true statement. Okay, plug a 2 in. So 2 times 3 minus 2 equals 2. Is this a true statement? Well, 3 minus 2 is 1. So 2 times 1 is 2. So that is true. All right, and then plug in the 3. So now we have 3 times 3 minus 3 equaling 2. Well, 3 minus 3 is 0. So we have 0 times 3, which is 0, which is not 2. So that is a false statement. So here, when h is 1, we have a true statement, and when h is 2, we have a true statement. So therefore, my solution set, my solutions are 1 and 2. All right, and then therefore, if those are my solutions, here's the little symbol for therefore. Therefore, the solution set is written with braces, and then 1, and then 2 listed out. Here's another example. This says solve over the domain of 8, 12, and 14. And you are told that 4 more than twice a number is 32. And the question is, what is the number? So I can do the same thing that I was doing before, but in this case we're plugging in a number into this English phrase. So in place of the part where it says a number, I can plug in the actual number. So for example, we're plugging in 8, 12, and 14, so plug an 8 in. So instead of 4 more than twice a number, we have 4 more than 8 is 32. So 4 more than twice 8 is 32. So in place of the word a number, we put the actual number 8. So 4 more than twice 8 is 32. Is this a true statement? So what is twice 8, or 2 times 8? That's 16. 4 more than that would be 20. Is 20 equal to 32? Well, no, that's not true. So plug a 12 in. 4 more than twice 12 is 32. So twice 12 is 24. 12 times 2, 24. 4 more than that would be 28. So is 28 equal to 32? Well, no, that's false. So then we plug in the 14. 4 more than twice 14 is 32. So twice 14 is 2 times 14, or 28. 4 more than that would be 28 plus 4, which would equal 32. So that would be a true statement. So because 14 creates a true statement, 14 would be my answer. And lastly, here we have x plus 3 equals x plus 2. This one is a special case because if you start plugging in numbers, there's actually no value that satisfies the equation. You can plug in anything. You can plug in a 0 for x. We have 0 plus 3 equals 0 plus 2. And that would obviously not be true. Plug a 1 in. 1 plus 3 equals 1 plus 2. That is also not true. There's no value I can plug in for x to make this a true statement. So because of that, therefore, that's the symbol for therefore, there is no solution. And this can be written in words, stated that there is no solution, or you can use this symbol right here. It's like a 0 with a line through it. And this means no solution or empty set. All right, that concludes our lesson for today.